We are here to walk you through a workshop on AI for nature and business. This may sound interesting because most of the time we are talking about AI for business. This time we want to talk a little bit about what AI can do to address the two biggest challenges and opportunities of our time, which is, of course, AI is a big transformational force, but also the environment is something that we are all concerned with. And probably these two, as they come together, present a great opportunity for us to do something different than what we did the last time over. Now, the agenda for this workshop is we'll go through fundamentals and ecosystems, AI fundamentals, as well as something about nature. We'll focus a lot of time on AI for business and look at where AI is impacting business today. And then we'll expand that to cover nature as well. Now, we'll start with AI under the hood, looking under the hood. And what many of you are already using, I guess, is AI in the form of things like ChatGPT. And most of the time, it's a black box. You just do your stuff, go and write some stuff, get some output, and that's AI for you. But what we want to take you a little bit under the hood is to understand how AI really works. What are the various issues around AI? Now, AI is mostly seen as a technology, but AI is much more than a technology, and we'll see that it encompasses many other disciplines, some of which are being addressed and some of it which still need to be addressed. Rohan may want to just quickly walk you through a little bit, and I'll work with him as we walk you through the details. So Rohan, I'll let you take over from here.
Sure, thank you. So yeah, as Andy pointed out, a lot of people just believe AI as a black box that is usually driven by data. You just feed in data into a model and it will start giving you insights or start predicting some values. But there's a whole lot of process that goes behind developing any model or any application. And I think this figure right below tells you about the entire AI life cycle. So whenever you want to begin with AI, the first question comes is, what is my task? And once you decide that I'll be predicting maybe the sales, maybe the demand for something, then you start questioning what kind of data would I need to make this kind of a prediction. So that's where the first question even goes, even before any models, before engineering or anything. It simply starts with selecting your data sets, which data do you need? Then from where are you going to get this data set? Does your company has that? Do you need to get it from open source databases that are available, maybe government information, government databases, or are you going to go ahead and collect it somehow? So those are the questions you will start beginning to ask yourself from the data point of view. Once you collect that relevant data, there begins the process of data engineering, where you will start beginning to explore it, understand what data is reflecting about, then sort of cleaning it up, removing any other inconsistencies in the data, starting to build features that could be fed into the models to train them. And then we begin to the part of the machine learning or the model building, wherein you feed the data and try with a couple of models, train them, see what output do you get, try to evaluate their performance, then pick the best model or maybe a couple of models. And then within those models, you will try to extract the maximum performance out through tuning them. I know there's a lot of engineering, but this is how the life cycle goes. It takes a lot of time. And even you might think I've got the best model out. That's not where it ends. You will just deploy it, and that's where the real challenges begin, because that's the first time your model will start facing data from the real world, and you will have to assess whether it's actually giving you some value, and then you will have to monitor it. And as it goes in process, you might have to fine tune it again and again a bit in a timely fashion, so that its performance keeps on improving, and it also adjusts to the changing conditions. So that's like a whole AI life cycle that it goes around a product, and it's just not like once you create a model and it's done. Apart from it, this was just like a engineering perspective that I just spoke to you about. But there are other constraints too. There are like the legal constraints. So from a government point of view, maybe if you're handling, let's say, medical data in US, the medical data is protected by HIPAA. It's a law. So if you're processing medical data, there are certain legal restrictions around it. You might have also heard right now, OpenAI is, and a lot of people are suing it, like New York Times, because a lot of their articles were protected by the firewall, but OpenAI still just scraped them and used to train their models. So there are a lot of legal issues with the data you're using or how you're processing it in your models. Then there is a whole other aspects of ethics and transparency. These ethics involves your models having being trusted, being reliable, and are transparent about the predictions they are making. Apart from it, there are biases, because a lot of time when we train this data, unfortunately, this data has some biases in our society that should not be but a part of the models. To give you an example, Amazon had a resume sort of a checker that would, if you just whenever applicants would apply for software roles, it would just pass through them, and it was biased against women. So just by reading the name, and if it could pick up the gender, and for a software role, even irrespective of what their qualifications are, it would reject them. They would not even make it. So Amazon realized a bit later, but it was because of the data they had on, and the data they trained it learned that maybe men are more suitable for software engineering jobs. So that's a bias. Lastly, there is the security per se, wherein, as I mentioned, it's just not about you using the models. Something like OpenAI, when you chat with ChatGPT, all those chats are recorded and they can be used to train the model by OpenAI. So a lot of time people use it to debug their codes, and in Samsung, some of the people use it to debug the code, and they actually got fired over it because it was a very sensitive code that they just uploaded it and trying to find bugs. So those are other aspects of security that you need to also look after when you are developing an AI. But now what I would like to do is take a step back and just discuss a bit more on what AI actually is, because this is what the life cycle is. This is how most of the companies function. This is how models are being put out today and the constraints around them. But what exactly is AI? I know a lot of people think, is ChatGPT the best model of AI? But it's just a very small subset. So yeah, I've got a good figure over here to explain sort of what AI is. So AI is a very broad area of research or a discipline within computer science that basically deals with technology that could enable machines, or especially computer systems, to simulate human intelligence. And when I say human intelligence, it could mean sort of things like learning, like we learn maths, we learn language. So such learning skills. Planning, we plan our day-to-day tasks, our routines. Decision making, we make decisions in critical conditions based on other factors. So such intelligence and different forms of intelligence, trying to mimic them. That's the whole purpose of AI. It's just not like generating text, but that's like the bigger whole subset, the whole set that includes AI. Within that, the most popular and the one that has sort of the business application is machine learning. Machine learning is a sub-branch within artificial intelligence, wherein the idea is to build algorithms and statistical models that could do a task for you without being sort of programmed particularly for that task. So you have an algorithm ready, and based on the data that you give it, it would learn the patterns from data and start giving you the relevant output. So that's where machine learning kicks in. I'll just like to touch base upon 3 other topics within machine learning very quickly on a high level, that is supervised learning, wherein you have what is called as the annotated or a labeled dataset. So for a given input, you are also providing the model with what kind of output I want during the training. So that's how your model learns based on input, what is the right output to generate, and it gets better as we train it. In unsupervised learning, we just provide it with data. There is no labels. You just, whatever the data you have, there is no output as such. You just feed in the data. And the idea from the model, or the expectation, is that the model will find patterns within the data and will give you insights that you may be missing out. And a very good example for this, where it is actually very heavily applied, is in sales and marketing, wherein people used unsupervised learning and they feed it with all the sales kind of sales data to sort of create clusters of customers and sort of segment their customers for like offers and other things. Like, these are the customers who buy it often, they buy it very few. Finally, we have reinforcement learning. Reinforcement learning is sort of like a game, or how actually humans learn, wherein you can imagine model being an agent and it's set up in some kind of an environment. It takes some action, and based on that action, either it would get some reward or it would be punished. And overall, it starts to learn to do the best reward. A good example would be like in business, how an employee works, and if he works a lot, he would get a bonus. So what we are trying to reinforce is that you keep working on harder and harder, and you'll get a bonus, like a cash incentive. So that's kind of like how agent would learn to perform a task. Whenever it gets it right, it would get a positive reward. When it does not, it would get a negative reward. So this was a little bit high level on machine learning. Within machine learning, a particular set of algorithms have kicked off in like the past 1 decade that everyone has been talking about. That is artificial neural network. The idea behind the artificial neural network was somewhere to mimic our brain. and just our brain is made up of neurons and they are all connected. That was the idea with artificial neural networks, to have such neurons where each neuron would slowly learn different patterns within the data. So that's what is neural network about. A deep neural network is nothing but a artificial neural network with multiple layers, maybe 16, 20, 32 layers. So that's your deep neural network. And within that deep learning space, right now we have a generative AI. And within that also we have one particular set of models called as transformer language models. And that's where our ChatGPT resides. So the ChatGPT, which I believe has now over 1 billion users, if I'm right, Andy, just correct me if I'm not, is that small of a subset within this whole AI sphere. And just so to like highlight that how big AI is, what are different areas. So this is where the AI is, and this is one way, sort of a more academic and a bookish way to look at AI in terms of fields. But there is another way of looking at AI that I'll just like to touch upon, and this is from your perspective or lens. So if you just look at the bottom left part, there are like applications. So if you are working with text, then there is the whole area of natural language processing that is a subset within AI. There is, if you're working with images, videos, you can look into computer vision that deals with images and videos. If you're working with robots, drones, then there is robotics, the area where you could look into. So there are, based on your application, there is one way of looking at it. Another very popular way of looking at it is at the capabilities of AI, the AI types based on the capabilities. So currently all our AI systems are called as narrow AI, because they can perform maybe one task like predicting the weather for a week, or maybe something like ChatGPT can perform a dozen of tasks like translating a language, writing a story, correcting your grammar. So, but still it's limited in terms of what it can do. Slowly, the aim is eventual goal is to move towards general artificial intelligence. That is where AI would be at par with human intelligence. So AI would be as much as capable as a human in terms of cognitive abilities. And finally, we go to super AI or super intelligence, where it would sort of go ahead and even go beyond our human capabilities to comprehend. So that's where I think pretty much everything would end, because AI would take care of everything. So that's one way in terms of its capabilities. Then, as I highlighted, one of the most popular things is artificial neural networks. So that whole becomes like another chain of looking at algorithms. And within artificial neural networks, there is shallow networks that have less number of layers, or maybe just one layer often, and then the deep learning networks. Finally, I would also like to touch base upon other algorithms that are quite famous and maybe not heavily used in business as often, but they do come up across. And as I mentioned, artificial neural networks were sort of inspired from human brains. These algorithms too have been inspired from maybe other basic sciences, or just other forces like physics, or other organisms apart from human. To give you a couple of examples, good one would be genetic algorithms that work on how our mutations happen in humans, like with crossover. We have swarm intelligence, wherein you have all small agents working together, having a common collective intelligence. That was inspired by bees and ants. So that's another way how AI works. So you can look at AIs from different perspectives, either from an algorithms, capabilities, or functionality. Finally, to circle back from where we started in terms of AI lifecycle, what I would like to do is lastly touch base upon the entire AI ecosystem that today exists in our world, the players and what they do. So in this whole AI ecosystem, at the bottom, I would say where who is driving everything, or is sort of like the fuel, is your computer hardware. At the end of the day, these are nothing but matrix operations that are taking place. It could happen in your laptop, but that would take maybe years to train the model. So that's where you need your GPUs and TPU. And that's where you have very few limited players, but big players like NVIDIA, which is now $1 trillion company. Going a step above, we have the cloud platforms. They provide you with a platform to sort of store your data. This is where model development and the deployment takes place. So some good examples would be AWS, Google Cloud Platform, Microsoft Azure. So that's where the cloud platform is. One of the layers I think that we are missing over here, and I would just like to touch base upon, it's not there in the figure, is the databases and other data engineering softwares. I think those are another very crucial component that come into this AI lifecycle. And good examples would be Qdrant, Vectorbase in database, and there is also in data engineering, we have Snowflake in open source, and Databricks is a good example for data engineering as well. So after the cloud, there could be a data platform as well, I feel, somewhere in this ecosystem. Once you have these things as your checks ready, that's where you come to the companies in it. And we have certain companies that builds foundational models. These foundational models are nothing but large models that can do multiple tasks, just like your ChatGPT is a good example from OpenAI. So you cannot repeat these models, you cannot recreate them because you don't know the data or the internal structure of the models. That has not been made public. That's why these are called as closed source foundation models. But what you could do is, now I have a ChatGPT and I could ask it to plan me a trip for a Delhi, like I want to visit Delhi and sort of roam around, see all the monuments. It can tell me, it will give me a list, it could plan an itinerary, but it cannot book hotels. It does not really know about flight tickets and other things. So different interfaces, something like, for example, kayak.com is very important, is a very good website for booking things. They have integrated ChatGPT and created a chatbot application for their users, wherein users could chat like this, just like this, that I'm planning a trip to Delhi, then to Agra, and they have the database of all the hotels availabilities, the prices, the policies of the hotels, what services they offer. So you could at the same time have a conversation and book them. So what you're doing is sort of creating an application over the foundation models. So this is a very popular approach wherein people, you have companies like OpenAI that just focus on creating such models, and then you have other application-based companies that leverage such foundational models from these companies and add a layer of intelligence or a more domain knowledge to it. And it's not that these models are only being developed in closed source. There are good examples in open source. For example, for text, there is Llama 3 from Meta that has been released. For images, there is Stable Diffusion from Stability.ai. And a lot of these open source models are available at platforms such as Hugging Face, where you can go and look for other models as well. So people either go with closed source, where you have to pay a good hefty fee, or you could go for free models and deploy them and use applications. So these are like two very popular strategy within these ecosystems. Finally, you also have certain companies that sort of build end-to-end applications, and a good example is Midjourney. So when I say end-to-end, in the sense they collect the data, they build a foundational model, a very large model, very capable model, and only they do not they keep it proprietary, and they build applications over that model. Only they build applications because they have access to that model. So complete end-to-end application development is done by them. So like this is the whole ecosystem within of AI. Andy, do you want to add something on?
Yeah, Rohan, thanks. Just wanted to add to what Rohan was saying. These technologies are constantly, transforming, as you can see. The core, of course, the hardware and especially the chip companies are probably the ones that are capturing the most amount of value right now. The large language models are evolving very rapidly. There are great companies. There's a company called Anthropic. Many of them are still privately held, so it's very difficult to invest in them. But Anthropic is probably the one that is going to most likely to disrupt OpenAI, at least they want to. And then there are, of course, others that Rohan mentioned. Now, what's its impact for us? Rohan and I, we were setting up the website for our original, when we started something called naturecentered.org, and we took a few quotes. And we got quotes from people in India, of course, who developed this website for a couple of lakhs, maybe 3-4 lakhs of rupees. One quoted for about lakh plus. And they said they'll take about 2 months to develop it. And what he and I did was sat down and became AI first. Took some of these applications that you see, a product called Relium, another product called Webflow. And we had a website ready from concept, which was in our mind, to actually launching the site in 1 hour. A working website was ready in 1 hour, spending a maximum of, I think, about $50 or $60. That's the power of AI. That's what it is doing to change things, and that's what it will do to even change the future of work. So really, I want to take this to the next step in terms of how AI is getting applied in business. And many of you are in business, some of you are probably a little bit away, but AI is everywhere. AI, any company worth its salt absolutely needs to have AI in their strategy. AI in their products. So if you look at John Deere, for example, it's an AI company now. It's got a humongous amount of AI. They have autonomous tractors. The reason why Tesla is really still being able to sustain its valuation is because people are presuming that at some point it will have a fully autonomous car, robotaxi as they call it. That is really sustaining its valuation. Recently, there's an AI company in US which flew an F-16 completely autonomously with an AI pilot. There was no human pilot in the aircraft. So you see AI everywhere. Some places you see it visibly. Some places, like in retail, in consumer products, you see it rather invisibly. But there is AI everywhere, and much of what you've just seen. There are three areas in which AI is being used, and three ways in which AI is being used. One, it is being used to scale. Scale as in, if 10 people if the job gets done by 10 people, and you want to scale it to 1,000 people, then you don't add 1,000 people. You just take 10 people and then use AI to scale it to the level that 1,000 people could do the job. So that is as a scaling agent. The second is as a co-pilot, which means that your job, you're still working with whatever the resource is there, but it just enhances and augments it. And I'll give you an example. Right now, I'm working with a company. I'm advising a company called Geminis. Geminis has an investment from Schlumberger, and they are creating co-pilots for industrial operations. So in refineries or in power plants, you've got all these systems which maintain and manage those equipment. And there's an operator there. And the operator has to take some decisions from time to time. A lot of it is automated. But even that operator now can be augmented with AI in a way that the person may not be required, or even if he's required in a very nominal way. And then, of course, autonomous systems, we've talked about that. When there's no more human in a loop, it's completely autonomous. So that is the journey that AI is taking in business, starting with scaling, and then some of the systems that were mentioned, intelligent automation, cognitive systems, robotics. Robotics has been around for a long time. Some of these systems have been in manufacturing there for a long time. So it's not like anything is new. What they call Industry 4.0 already had a lot of these things. But now they're calling Industry 5.0. That's a new term. We always need a new term to keep people in business. And that term includes more of cognitive systems, more of systems which are focused on taking human as little in the loop as possible. I don't want to call it human completely out of the loop, but human. And again, we can have a discussion around each of these industries. Each of these industries has a lot going on. Finance, Venkat, I'm sure you know a lot of AI going on in the finance industry, where there are quant funds, which are AI-driven quant funds, which are currently outperforming any portfolio manager or any hedge fund. So these things are now there and around us everywhere. Now, where is the connection between nature and business? And here I want to take a little bit of a segue to start talking a little bit about nature and why this connection and why the need to include nature. Now, what I'm sharing with you is what is called the 5 capital model. The 5 capital model is a model which looks at how capital is formed. And most of us look at capital formation, a good metric being GDP, as manufactured capital, financial capital, and we add a little bit of human and social capital to it. If you take the world's GDP today, it's about 110 trillion. You can give or take a few trillion, but that's the size of the global GDP today. All of this is nested within natural capital. It is the earth and our ecosystem which sustains everything. BCG in a recent report estimated that this natural capital is approximately $150 trillion. It could be more, it could be less, but roughly. The 5 capital model really shows us that the constraining factor of our growth is really the natural capital. It's only the amount of resources that we have. Now, just to give you a sense, just last year alone, thanks to AI, thanks to a lot of stuff that we are doing, thanks to solar, all the stuff that we are doing now in the name of improving the environment as well, more minerals were extracted in just 1 year than all of from the advent of civilization till 1950, including the 2 world wars. just in 1 year, we have extracted more minerals. And I'm sure Ajay will give us more color to it. He's in that minerals business as well. But that will give you a sense of how much this natural capital is under stress. Now, BCG has estimated that we are losing $5 trillion of natural capital a year. 5 trillion. Imagine more than the entire economy of India disappears every year because of the way we are extracting this natural capital. And this is coming through all the stuff that we are doing: food, infrastructure, mobility, energy, fashion, everything that is extractive in nature. That's how our economic model is set up. Now, just to give you a sense, since we are in biodiversity, I'm switching gears a little bit. I'm sorry, we're moving from AI to biodiversity, and we'll come back to AI in a bit. But just so that everyone is on the same page of what biodiversity is, there's 3 ways in which biodiversity is looked at: genetic biodiversity, species biodiversity, and ecosystems biodiversity. And this is around the marine, terrestrial, and freshwater. And much of our attention is on the terrestrial part of the biodiversity because that is what is seen by us. But the one that is most under stress is marine and freshwater. And that has a huge impact for us in the long run. Now, one of the things that we are looking at in AI, as we try to look at what the future will look like, is today there's a good understanding of what is sustainability. Everyone is wanting to have a net zero, carbon neutral kind of approach towards things. We switch off lights, we do all kinds of things to we conserve the environment. But really, sustainability is what someone said is a slow way to die, a slower way to die. Because sustainability doesn't really get us to a place where we can still save ourselves from this environmental degradation. There's a new thinking which has been on for the last few years called regenerative thinking, which is regeneration, which means really looking at the way ecology, environment behaves, which is constantly regenerating. It's a living system. And this is where we are going in terms of looking at how to look at these different aspects of manufacturing and economic value creation, and how do we make them all regenerated? Because once we get into a completely regenerative mode, then we are no longer worried because we are doing things which are net positive, not just net zero. Now, what we are trying to do here is, as a team, is trying to connect these 2 dots, which is nature and business. Now, one of the big topics of AI, which is not fully, or I would say, not talked about enough, even though a few people are talking about it, is that AI per se has a significant impact on the environment. For example, right now, the US, in spite of being energy and power surplus for a long time, for the first time is finding a shortage of power, and primarily driven by the explosion of data centers that has happened. Initially, it happened because of crypto, but now it's more happening because of AI. So, and of course, you see chip design. Anyone who knows what semiconductor design is, it extracts a whole lot of minerals. It uses very toxic acids. I've worked for a semiconductor company in my life before. So, and the environmental impact of AI per se, just the usage of AI, and the more AI every time, and we'll talk a little bit about what it means when you use AI, even like the chatbot. The second is we're looking at how do we use AI both as a co-pilot as well as an autonomous agent for regeneration. And we'll talk a few examples of it. And the last thing which we want to talk about is what is AI in this new world when it becomes AGI. Rohan briefly touched upon this when he talked about narrow AI and artificial general intelligence, but we'll talk a little bit about this. Very quickly on green AI, I've already covered it, but just to give you, every time you go on a chatbot, you are actually lighting a bulb, equivalent of lighting a bulb somewhere for a few hours, depending on how much time you decide to sit on a chatbot. Now, we are much more careful about our bulbs now. We're replacing it with LED, but we are not that careful about AI. We think it all comes free. We just go on to chatbots and keep using them. So here we are talking about how we can help in reuse of models, optimizing models, carbon costing of models, etc. Regeneration, there are 3 aspects to regeneration. The biological ecology itself, which is all the stuff that is around us that you can see behind me. How do we do forest cover mapping, wildlife management, human-wildlife conflict, use of things like AI-powered drones. Industrial ecology, this is a new term that is increasingly being used, which is how do we bring biodiversity in the process of design, manufacturing, and reuse? How do we design for biodiversity? How do we manufacture for the biodiversity, and how do we reuse for biodiversity? Now, Rohan and I also are associated with a bunch of new initiatives with different players, mostly in the Silicon Valley. I'm heading actually tomorrow to Palo Alto for a conference in Stanford, where there's a whole discussion about how to use, technology, but also regenerative thinking in the area of the built environment, in materials, in fashion, in those kind of areas. And again, in each of these, we are trying to see how AI can be used to accelerate things that are being done. Now, the last element, I think Venkat had forwarded to us this thing about a robot jumping and committing suicide. I don't know how many of you have seen this movie called I, Robot. If you've not, maybe it's a good idea to see it once more. Will Smith's movie. It's set in 2035, just 14 years from now. It was the movie was done in 2004, and it talks about how robots who are actually doing menial tasks are actually secretly conspiring to actually take over. And that comes from this whole concept of artificial general intelligence. AGI, once it's developed, and we don't know when it will be developed, or probably it's already been developed somewhere. If I look at that robot, it scares me because maybe it is already. It's said that AGI will come in about 10 years from now, but many people are thinking that it's already in the lab somewhere. AGI, once it's developed, will probably be the last AI that will be developed by humans, because from then on, AGI will develop AI, because it'll be so much more smarter than us. And that's where we see the role of AI, because there is something, and if you remember what Rohan showed you, he showed you those 4 or 5 layers below the technology layer. And within that, there's something called a value loading layer. And the value loading layer is where ethics, bias, all that stuff is going on. And we think that, nature presents itself as a way to create a set of values that have actually preserved us as mankind and as a species. And we believe that those values should be inside AI. Now, there's a lot of talk about human-centered AI. Stanford has a human-centered AI as a part of its a big center. But our belief is that nature has to be a stakeholder, not just humans, but nature has to be a stakeholder in this entire AI, evolution. And this kind of thing we are talking about is, it will require more than experts, the technology experts that Rohan and we are. It will require a lot of different kind of people, social scientists, philosophers, etc., to come into play. And some of this is happening. Some of this thinking is happening. We presented this, by the way, at the AI. The UNESCO conference on ethics of AI. So some of this thinking is happening, but there's always the worry that technologies will always go a little faster than what we anticipated. So very quick takeaways, and then we'll leave this floor open for discussions. Is AI is clearly the biggest economic transformational force, but it's not just an economic transformational force. It is technology, it is the future of work, but it has a deep and a significant societal impact. And that societal impact is not yet visible. This is not just another technology that has come in. This is something that is going to foundationally change the way, everything will happen around us and within us as well. Second, from a pure nature perspective, business, we've discussed what, and many of you being connected to business already can understand that, but nature itself, there are many impacts. The good news is that unlike in the past, we messed up the Industrial Revolution from a nature perspective, and we are seeing the results of it. We have an opportunity to do something different this time over, where we can leverage the AI revolution, but ensure that it focuses more on a regenerative approach rather than just a degenerative approach that the early revolutions did. And then our approach has been to look at how to facilitate this transition from what is called an extractive economy to a regenerative economy. Okay? So with that, I will close, and we'll come back